Awesome. Well, what I want to do is I want to jump into a few different things here. Number one, I want to just quickly go over a MERN stack. We've heard about it. We know what it stands for. It's Mongo, Express, React, and Node. And as you go into Google and you type in MERN, all of a sudden you start seeing entries for mean and other things like that. So just so that you know, MERN is a full JavaScript stack. It's designed to be compartmentalized. This is one of the few stacks that are really, really good at saying, I can swap out a piece anywhere I want. If I didn't want to use Express, I don't have to. I can ditch that and use just Node. If I didn't want to use Mongoose, I could just use the MongoDB driver. If I wanted to use something other than React, I could use regular HTTP and JavaScript. I could use Angular, which is the competing idea to React. All these pieces can be swapped out. And so it's important for us to recognize that these things are compartmentalized. In our process, we're going to create a React server. It's on the front end. And that React server is going to listen to a request, and it's going to give almost our entire website to the client browser. And the client browser is going to hold on to that React code, and it's going to react to the things that people click on and do. That in turn will ask for information or put information over into our backend. Node is what runs that server. On top of Node, we have the Express web framework and we have Mongoose that make our lives easier. I say that these two things are very similar to jQuery and JavaScript. Okay, JavaScript is actually the one doing everything, but jQuery added syntactic sugar. It made it easier to use JavaScript. Same thing with Express and Mongoose. They sit on top of Node and they make it easier. It's nicer and simpler to use. And then Mongoose is going to talk to the MongoDB. The database is the one that holds on to everything forever for us. Until we tell it to delete it, it's saved. And anytime somebody asks for it, I can give it to them. Anytime they want to put something in there, I can put it in there. And so the way it goes is the client uses React to request something, comes over to Express. Express says, yeah, I know where to find that. I'll talk to Mongoose and have him go grab it. Mongoose says, okay, I'll go grab that. He grabs the data. It comes back through Mongoose. He hands it to Express. Express says, okay, we got the data. It looks pretty. We're going to send it back to you in a JSON format. And React receives this JSON format and says, I can make that look pretty. And it puts it onto your browser, and voila, the MERN full stack in action. So everybody is responsible for their own pieces. React makes things look pretty and listens to what people tell him to do. Node is responsible for listening for requests, getting the data, and sending it back. And Mongo just holds on to things and says, hey, you tell me what you want. If you want me to hold on to something or you want me to give you something, happy to do it. You just tell me. So now, with an understanding of MERN, it's also, here's another way of looking at it. On the client machine, inside the browser, we have React. And React has the application that we, as the full stack developers, have created. And that's where we start talking. And we get the API. That's an acronym for Application Programming Interface. We'll talk a lot more about that in week 4. But just kind of the way these things stack on top of each other is a great way of visualizing this. Any questions about MERN? Awesome. then I guess we're in the right class. So, as you guys know, there's different ways to use JavaScript. And I'm not going to jump into that because you guys have been practicing that and playing with it all along. In your web fundamentals, you guys got into jQuery and JavaScript pretty good. You recognize that we can go into an HTML file and add a script tag. We can also use Node at the command prompt. Have you guys used Node at the command prompt, and then also you can use JavaScript in the console for the browser? You guys have questions about any of those?
Seems to make sense so far.
Okay, good deal. Well then, in that case, let's jump right into scope and hoisting. Okay, now scope is one of those things that can be very confusing if you don't quite understand it. Scope, the way I look at it is, can this section of code see that variable? Okay, it's kind of like me. If I look out my window, can I see the airport? No, I can't. Can I see my neighbor's house? Yes, I can. Okay, it's not that it doesn't exist, that airport. I know it exists. I just can't see it. I can't access it from my house. And so in programming, we have to worry about scope. Now, the trick with scope is it's handled differently depending on which version of JavaScript you are, or I should say ECMAScript, the standard for JavaScript. If you are using ES5, which was the standard before 2015, then you have to do it one way. And if you're using ES6, which came in 2015 and forward, then there's a different way of using things. And it results in all sorts of crazy behavior. So I want to point out to you, I just went ahead and grabbed from the platform this particular code. And I want you to kind of look at some things. Number one, the word function. Function is a very important word for us because functions allow us to see the information that we want and kind of shield it, if you will, from the other places. If I had 6 airports inside of my code, well, each one of them is going to have airplanes, and I don't want them seeing each other as airplanes. So I could put them inside of a function, and that function would have its very own set of information, and I can focus on that. So every time I see the word function, I want you to think this is a brand new scope. I can see different things here. Now, if I declare a variable like Beatles up here at the top of my document, before I go into any functions, that's considered a global variable, meaning I can actually access that in any function that's inside, or a child, if you will, of the global scope. So any functions can see Beatles. If I look at var name here inside of this function, I can only see that inside of this function. That's the only place I can see var. And inside of this function, this bigger one, I cannot see name. It's hidden. It's inside of that other function. It's protected from me. But if I were to make a different variable up here, like var airplane, this one is now going to be available inside of this function, and it could be seen inside this function because this function is also a child of the, this function is a child of the other function, so I can see it. Last but not least, we have the global context, and as I mentioned before, the beetles can be seen inside of any function, including down here when I finally get past all the functions. So scoping is, in some languages, scope is defined by curly brackets. Other languages, like JavaScript, ES5, is going to be based on functions. Now, you're asking yourself, why do I need to worry about this? As we come forward and we start looking at arrow functions and things like that, it makes a lot more sense of when I need to be able to access things inside of a function and outside of a function. And if you think about it, I'm probably going to want to use name as a variable somewhere in the 300,000 lines of code. And I'm probably going to want to use it in more than one place. So as long as I'm inside of functions, I can create as many variables as I want. Now, the trick is ES5 uses a keyword. That keyword is var. var is a wonderful tool. Everybody needs variables, but they found that it caused some problems and it was actually intentionally designed that way. Now, here's what I'm saying. When I look at a variable and it's inside of a function or any other time, a variable is like a balloon. It's kind of tied to hot air balloons, right? It's going to come, and if I had a function keyword here and variable was somewhere down the line, that variable is going to get moved up to the top so that that variable exists. But it's going to wait until I get down to this point before I actually give it a value. Now you ask yourself, what's the point in that? If I'm getting something undefined higher because I'm using it before I gave it a value, it's because the internet is designed, we don't want it to break easily. We want our application to either show bad data, no data, but we don't want it to error out. And so they intentionally wrote it so that if somebody made the mistake of referencing a variable and it was before its time, it goes, oh, that's okay. We'll give them a value and pretend that they had done it right. And so it may be undefined, but at least your web application shows up and can give people information, even though this one color was wrong or whatever ended up being blown up. And so that's why in this one, var was designed to float to the top. Functions are designed to float to the top. And so those things, as we look at it, it's called hoisting. And we're going to go, get rid of that, and we're going to move over to hoisting. Now, hoisting here, this is a very simple example that we have, but I want to show you how it's done. And I want to point out something. If you go looking at the solution in the platform, the solution is not going to follow the same rules in its answer that I'm going to give you. We're in the process of correcting that because people started asking a question and I went back to the ECMAScript actual, the design specs for ES6 and found out that things float differently. It's actually done in a multi-check process. So the first thing to float to the top is functions. The next thing to float to the top is variables. And then everything else happens in place. So if we look at this particular version, our programmer, he wasn't thinking straight. He went ahead and called his function before he had even defined what the function was. He went ahead and created a variable and assigned a value, which is perfectly legit, right where he wanted it. And so when we start looking at this hoisting, what I want you to do is I want you to realize that to prevent errors, they have allowed things to float to the top. So the first thing that happens is actually we take this function. A function is going to float to the top. And it's going to be the very first thing. And then the next thing to happen is we're going to get our variable. But the difference is it doesn't give it a value yet. Now that I've moved both the function, because the very first pass I grabbed all of the functions. I could have 15 functions. They all get moved up to the top one at a time. The first one I run into gets moved to the very top. The next one I run into goes directly below the first one, and so on and so forth. Then I go to variables. And if I did something like this, var bar equals, in all actuality, I wouldn't have moved the function up. I would have only moved bar. So I'll show you that in just a second here. I'm going to first finish out the example we started with. So function moves up, variable moves up, then the variable gets a value. It just takes that variable and gives it the assignment. Anytime I see an equal sign, I want you to think of it like an anchor. Okay? That portion of the command, whether it's var bar equals function magic, anything after the equal sign stays right where it is. It doesn't budge. Okay? And so then what I do is I get my, after I've made that just kidding. Before I make that assignment, I'm going to actually call the magic function. Then I'm going to make the assignment because I'm starting at the top. Everything is sequential. It goes one line at a time. And so after I've floated everything to the top, then I just start at the top and I work my way down. So magic is next. Then I make the assignment, foo equals bar, and the function doesn't exist anymore. It moved all the way to the top already. And so now I got a console.log. Now this is the way that JavaScript interpreter sees the code. This is the way it was written. And by doing it the JavaScript way, it made sure that we didn't have errors that stopped the program from continuing. Now, like I said, if function was var bar, then we would actually have it modified just a little bit. If var bar equals this, then what would happen is we would end up with var bar, and my function would actually fall down below that because the equal sign acts as an anchor. So bar equals magic. And in this case, it would cause an error because we try to call a function before it exists, because this would actually have to be bar. Just kidding. That would have to be bar because magic doesn't necessarily exist. We had assigned it to a variable. So lots of craziness here. So let me ask you, what questions do you have? You got a question for me, Travis?
Sure do. All right, I'll start. Okay, so based on how this is set up inside of the function magic, in this case, bar is called bar is essentially being equal or anchored to magic.
Mhm.
And in this case, it's making foo, which is totally independent of the foo declared above it, hello world, and then it's console logging foo, and then it's also declaring foo at the end as well.
Yeah, that's
Yeah,
actually a great catch.
yeah.
This would float to the top, and its top is the word function.
Hmm.
Function is like a ceiling to variables.
Yep.
So great catch there, actually. So var foo here inside a function, even though it has the same name as this foo up here, it's like, hey, I have my own copy of foo, so I'm going to ignore the one that's in the global context up
Hmm.
here at the top.
You actually did bring up a really good point, and I actually it's funny. This is the kind of fundamental concept, but I hadn't heard it phrased that way. And I think that it can't be overstated to where if you're using a variable that you like to use or something that's kind of common, yeah, using functions to be able to use a variable that is easy for you to keep track of, I think is really important. And yeah, I really like how you worded that as far as like when is a good idea to utilize functions so there isn't confusion, like even if it's just for your own sake, I would imagine.
Absolutely. It's a great way to work with your own stuff. And if it did exist elsewhere, I can override it and just say, I want to use my own copy. I'm not going to use the one that's out there.
Yeah, it's smart.
Mhm. Awesome.
Real
Any
quick
other
question.
questions? Yeah.
Yeah, the function of magic. I always thought the equal sign is more of an assignment. So like whatever the function magic returns is going to be assigned to bar. Is that really calling the function bar?
It's actually not.
Yeah.
So here's the distinction. Okay. When I have the keyword function in front of it, I am defining what that function is going to do when I call it. Whereas when I come and I use the name followed by the parentheses,
Mhm.
that is invoking or using the function. And so this right here is defining what I'm going to do with it. And then this would be a invocation. Now, you've got a valid point in the fact that, if I'm looking at this and I say var bar equals, um, so let's just do it this way. If I did var bar one equals, um, let's just take this out. If I had defined the function here,
Okay.
var bar equals magic, then whatever magic returns is going to be assigned to the variable. But here I've invoked the function by using the parentheses. The keyword function decided this is the definition.
Okay.
Does that make sense?
It does. And then so let's go back to the bar in parens in line 20. So that is not calling any function. That would throw an error because there is no bar function because function magic, whatever that would just return the console log foo, right?
So yeah,
Oh,
so this one,
hello world, right?
well, the trick here, this is kind of an interesting thing about uh, JavaScript. I can take this function and technically I could take this function and say this. This function is what's referred to as an anonymous function. It has no name, it's just a function. And I assigned this function as the value to this variable called bar.
Okay.
So in this case, I can do this sort of thing here, and the function now has a name. I can still use it just like I would otherwise, that bar with parentheses to invoke it. And there are certain times when doing this specific thing is exactly what we want to do in React.
Okay.
And so we'll cover some more of these things coming up. But yeah,
So,
we'll use a lot of arrow functions and things.
so the equal sign does, will assign the name of that. Okay, I think I got it. Okay.
Yep, we're assigning that entire function to a variable. Yep. So
Okay.
another question, yeah.
So when you make var, let's say you have that anonymous function and you place var as bar, it's mutable. But if you put a const, would that change up anything, or could you change that name further down the line in code and cause an issue if you were to say var bar? Would that break some code?
So if you were to make it a const, you'd still be okay. And the reason for that is the function, we aren't trying to change it at all. And so if I change this from var, sorry, just one second here.
I mean, like further down, let's say like 100 more lines down of code, and we said let bar be equal to y or something. Would that break anything else that you had previously said bar if you needed to call that anonymous function? Would it be?
No, it would be okay. The thing that you would run into is if you said, you know, you get 100 lines down and you say bar equals 10.
Okay.
Okay.
Maybe that's what I meant.
Const would prevent that. It would actually, the JavaScript interpreter wouldn't let you run the code because const is that's a ES6. It's a ES6 keyword. And if you're using the ES6 keywords, hoisting doesn't apply. Okay. If I make it const, it's going to stay exactly where it is, where it's written. It doesn't float up. Only the variables, the bars, will float up.
Okay.
And so, but const, it just says, you're not allowed to change it. You assigned it, you meant to keep it constant, so we're going to keep it that way. If I were to use let, that's a, hey, I'm assigning it a value now, but I want to be able to change it again later.
Okay.
And so, yeah, and let and const, they just say, hey, I'm staying right here. No floating for me. And as a result, the JavaScript compiler, the interpreter could say, hey, wait, you misused this. It's a nice thing. I always tell people, use let and const in your code. And whenever you can, use const. It's just a better approach to making sure that you don't accidentally change something. So.
Quick question. So how do you call this function when you say var bar is equal to function magic? So is it how the line 21 it is called like that?
Yeah, so you would just go ahead and on line 21, that's exactly the way you would do it. You use the variable name and then you use the parentheses to invoke it.
Whether it has a name or it doesn't have a name, right?
Yep.
In both ways, this is the way to call it.
That's correct, because here I gave it a name in a sense by calling it a variable.
Mm-hmm.
And so this, even though it's an anonymous function, it kind of has a name because I have to be able to reference it later on. Or if I use an anonymous function, I can make an anonymous function run right now.
Hmm.
And so that's another reason for using anonymous functions. But this is specifically if I wanted to call it and I use that var bar, this would be the syntax that I would use to invoke that method or
Got
that
it.
function.
Sure.
Awesome. Any other questions?
Is there a quick way to change from ES5 to ES6 interpreter in Node.js? Is there a way to have your compiler switch versions?
There isn't that I'm aware of, no automatic way of doing it. In a lot of the things that I've done in the past, I've just gone in and done a find and replace and replaced var with let. And then I ran it through the JavaScript interpreter and had it blow up and tell me where I needed to move things.
Okay.
So yeah, that is a great question. There's usually a lot of different things, but ES6 is fully backwards compatible with ES5. So as I change things to ES6, even if somebody's using an older browser, as long as I'm not using ES6 specific functionality, the interpreter can read both 5 and 6.
Okay.
Great questions. This is an awesome class. All right. Well, I'm going to try to kind of rush through a few different things here that are in the platform, but I wanted to just touch on them because these are concepts that we're going to be using a lot later on. Okay. Destructuring is one of these concepts that we're going to want to kind of get used to. Now, you're familiar with objects in JavaScript, and this is a complex object. It has keys and values, and then inside of it, I've got a key for addresses, which is an array, and that array has objects of its own. So element 0 is this address, and element 1 is that address. It gets kind of crazy and in depth. And arrays, they have no keys. They've only got indexes. Now, before ES6, to get a particular piece of information out of this person object, I had to specifically say this person dot key, in this case email, is assigned to this local variable. And that's cool. I can do the same with animals. I can say this index is assigned to this local variable. ES6 recognized that we were doing this over and over and over. And not only that, but typically when you pulled things out of an object or out of a specific array, what we wanted actually a whole bunch of information from it, but it was just a subset of the information that was contained in the original structure. So what we did is ES6, they added a thing called destructuring. And what destructuring is it allows you to create a local variable name, and inside of that local variable name, as long as it matches the key up here inside of that object, we can say, okay, just give me the object and point me to the key, and I can make a local variable for you with the exact same name. It has the exact same value. And all I have to do is, depending on whether I use curly brackets for objects or I use square brackets for arrays, just the way I write them in JavaScript, only I'm doing what's called destructuring. And so this animals array, I can get the very first animal out of it by using these square brackets and saying, okay, here's the name of the local variable that I want you to assign element 0 to. I want you to go into person And I want you to grab out the email key and assign it to this local variable email. Now, that's nifty, but it seems kind of overkill if I just really want one thing. In React, we're going to use these things a lot, and specifically with objects. We're going to want to be able to pull things out without having to make a whole bunch of these lines. Technically, I could have an object that comes in with 50 items in it. I can assign 6 different things in this one line and get those 6 pieces out of the 50. And so if I was doing multiples, here's the old way, and here's the new way. We've got first animal, third animal, and you'll notice the commas here. The commas tell me which index to go to. This is index 0. I've got index 1, which is our empty space here, and index 2 here. And so I can give myself local variable names for every one of those pieces, and it all comes from this array. I don't have to give an index to assign each one of those things. Inside of my person object, I have lots of different pieces of information. Among them, I have a password, and I also have an email. And so I can grab out both pieces of information from that object with this one single line. Now, this colon that you see right here, that colon is indicating, hey, inside the object, we call it email. Outside the object, my local variable name, I want it to have a different name than email. This is one way. If I've already got a variable called email and I'm pulling the email out of an object, I can give it a different name. And so this is my local name. So I've pulled out information very simply from an external source. That object, I pulled out the individual pieces that I really wanted. And so this is one of those where we need to be able to understand how this all works, right? And so now what I'm going to do is I'm going to come down. I can grab out of that nested key the addresses. And here I've given the names because I'm using the array syntax for destructuring. Index 0 and 1 addresses, I gave them local names, White House and Sherlock, which, if you look at it, this is the White House's address, and this is Sherlock Holmes' address in London. I gave them a name so that now I can easily access them inside of my own function, inside of my own block of code, whatever I would like. And you'll notice that I use const. I do not intend to change the values of these local variables. I intend to keep them intact. So I used const. If I want them to change, I need to change it to let. All right. Now, hand in hand with destructuring is the rest and spread operators. This one I kind of use just kind of a way of talking myself through the code. So using that same destructuring for arrays, because I'm using square brackets, I'm going to look at this array and I'm going to pull out the very first element, which is first animal. My comma tells me to move to the second element, and I get the second element here and a comma. And then I say what I want. These 3 dots are known as rest operators, or they are spread operators, depending on what I'm dealing with. When I'm dealing with arrays, this is the rest of the array. My rest operator is going to give me the rest of the array that I haven't gotten so far as I went through all my commas. And it assigns all the rest of them into this local variable called other animals. All right, so it's the rest of the array. Now, if I want to deal with objects, what I want to do is this spread operator, okay? The spread operator is a really cool thing. And this spread operator is going to be used in key places in the React code. Now, what this, in a sense, is doing is I am taking all of these pieces of information, and I'm, in a sense, doing this. Const person copy equals and what I've done is I have spread out all the keys and values that exist inside this person object, and I have spread them out into a brand new object. That's what these curly brackets are doing. They're saying create a new object, and I'm going to spread out all the keys and values from the person object inside of this. And I'm going to make that now available to this new object. And so when I say create a copy of this person object, all I had to do was do this spread operator. It doesn't matter if person has one key value pair or if it has 5,000. That spread operator has just duplicated all of its stuff for me. Now there's a certain hiccup or exception to this rule, and that is if I have another object inside of this one, it's going to say, okay, I'm going to point to the original for that one. That one's kind of a more advanced topic. We'll probably cover that just as we get into our towards the end of React, and we're duplicating objects and stuff like that. So just know that there is a little bit of a caveat, but in a sense, this spread operator, it's spreading out all of the pieces that are inside of this object so that I can make a new one. Very important ideas of
Yeah,
rest
it's pretty
and spread.
powerful.
So is there any questions about deconstructing and rest and spread?
I have one about spread.
Yes.
So in JavaScript, we can easily make objects, new objects by saying new. So that doesn't copy the values, but this one is exactly basically making a copy, a duplicate. But then what is the purpose of this one? Why are you doing this?
That's a great question. And so inside of React, as we start dealing with certain objects that get passed around inside the code, those objects become what's called immutable. They're constant. You can't change the value of them. In order to get a copy that I can start manipulating and changing, I need to use the spread operator to copy it over to a temporary variable so that I can make the changes as I go through the code.
I see, got it.
And so, go ahead.
Then that time, do we make it let or const? Because if we make it const, we'll get into the same thing that we cannot change it, right?
So that's the fun part about const. Const is saying I can't assign a new object to this variable. but it doesn't mean I can't change the value of a key.
Oh, I see.
So I can change the values inside of this object. I can't create a brand new object and assign it to this variable.
Got it.
So great question. That's a great catch on that one, because that is, you're sitting here const, but we're changing what? So here's an example right here on line 60 of using the spread operator to create a copy, but then overriding something that's in there. This is the exact syntax that you're going to use in the React program. And so what you do is you make that full copy of everything, right? And then I have a comma to indicate I have a new key to add to this object. But since I'm using the exact same key as already exists in there, the interpreter says, oh, you're giving me a new value for that key. And so I can then overwrite something inside of the brand new copy. And so now I've updated using the original object. I've made a copy and updated it at the same time. All right.
Got it.
Kind of crazy, but it's really, really cool, because if you manually have to copy all these pieces and work with it that way, it's a nightmare. But these little syntax changes that have happened with ES6 are awesome. All right, arrow functions. To be honest, they're super, super easy. Okay. This function is written in ES5 notation. It's ES5 syntax. Function, it's an anonymous function, meaning it doesn't have a name. We assign it to a variable. But this function takes in a single parameter and then it does this stuff. Well, if I wanted to change this to an arrow function, all I have to do is eliminate the keyword function and put what's called a fat arrow. It's an equal sign followed by greater than sign. It looks like an arrow. And what happens here is this allows me to do the exact same thing. It's an anonymous function. It takes in one parameter, and you're sitting here thinking, okay, so I don't have to type the word function. That's true. But now let me ask you something. If I looked at hoisting and I remove the word function, what happens? Remember, in our hoisting, we said that in our scope, right, we talked about hoisting. Variables and things, they got moved up. And they hit function and they stopped floating to the top. If I remove the word, let's see here. If I remove the word, got to get my arrow function back here. If I remove the word function and I declare something, how far can it float?
Does it
Would it?
stay?
Go ahead.
Oh, go ahead.
It stays, right? Because it doesn't float up like it would as if it were declared a function.
So a const would not float. But if I made a variable, okay, then this variable would actually float because it can go past, there's no function name, no function. So I can float all the way to the top.
Oh.
All right.
But then the scope will change, right? This is still a function, right?
Mm-hmm.
So right now it is ES6 say hello. The scope is only limited to the within the block, but if it floats up, it will become global.
That's correct. And so by removing the keyword function, it allows things to go up. But the other thing that it allows is I haven't created a new scope. And so things can flow easier into it as well. Specifically, when I'm dealing with classes, we're going to see this. We're going to see how the keyword that you guys ran across in your web fundamentals, this, okay, this keyword is actually prevented from entering where I've used the keyword function. But if I use an arrow function, that variable this can now come down and become a part of it. And so I think I've got an example of that here soon. So by eliminating the keyword function, I've changed the scope. I've changed where things can float. I can change where things are accessed, right? And so let's see here. As I come down, I can see the old way of doing ES6 is here, right? I've got the function keyword followed by my parameters and then the block of code. If I look at ES6 notation, I can use arrow functions. Now, arrow functions, they also have other perks in addition to just not having the keyword function. By default, if I have only a single parameter, I don't have to have parentheses around that parameter. Personally, I don't like that. It's harder for me to read fast through the code, but it's perfectly legit. So that's totally up to you on how you want to do it. For me, I prefer putting parentheses around something that's going to be a parameter. If I have more than one parameter, I have to use parentheses, no matter what. Then the arrow function says, okay, after this is the instructions, the statements, the expressions that you need to execute when you run this function. By default, if I only have one instruction, one statement or expression, it's going to automatically run it and return the value from it. I don't have to type return. It just automatically does it for me. So in ES6, the add function could look like this compared to this. So as you're looking at your Stack Overflow and stuff, just know if you're seeing something that has an arrow and it has one statement, it's automatically returning that. Now, if I have multiple lines, I still have to use curlies. So multiple parameters need parentheses, multiple statements require curly brackets to create a block. If it's one single statement or one single parameter, this is perfectly legit to return the value n times n. All right. So as you go through, there's some assignments that are coming up and they're saying, okay, we want you to do hoisting. And we want you to do it in ES5 and we want you to do it in ES6. Well, ES6, just change var to be let and const. Just like we did in our hoisting example here. You're going to write it out the way that they have it. You're going to write it out the way the interpreter sees it. And if it's a const or a let, just remember, it stays put. It doesn't float. Anything after the equal sign stays put. It doesn't float. And when you look at the solution and it has the variables above the functions, don't freak out. Just remember, if you've got your variables and functions up at the top, you're right. Okay. All right. So, any other questions about this?
So maybe not use var when we are doing arrow functions.
Absolutely. I will tell you, just do not use var. You'll be perfectly fine without it. Okay. I know in Web Fundamentals, everybody talked about using var. That was what you used. Now's the time to break that habit. Unless you have to have ES5, use ES6 standards. So much of the industry works with it. There are old browser requirements depending on what company you're working for. Remember, ES6 has been around since 2015. If you're working on code that's older than 2015, or maybe 2016, 2017, they probably should be looking at updating it anyway. But I don't get to determine how the company you work for runs their show.
So
Not yet.
for hoisting, right, this thing var and function floats up. But for ES6 and above, if we don't have var, but if we have function, function will again float up, right?
That is correct. Functions will always float to the top, and that's perfectly good.
And if we don't have the word function, and rather if we have arrow function, then nothing will float.
That's right. Exactly. As long as you're not using var, if you assign your function into a variable, then it will stay right there. That function will not float.
Got it. And arrow function always need to be assigned like this, like const something is equal to. Arrow function cannot stay on its own like a function.
That's correct.
Got it.
However, we do use arrow functions inside of our code at times without assigning them to a variable. So like an on-click event, I could use an arrow function right inside of that. I could say on-click arrow function. And it could take in the event as a parameter, and I could do something with that event right there. Now, if it's something super simple, like assignment, then okay, great. But if it's going to be more than a line, I suggest you create a function just like this, and then you refer to that function inside of the on-click event.
Got it. But
So,
arrow function cannot be used just on its own. It has to be called or used with something.
yes, that's, if you don't, it will not give you the things that you expect. So you can get some
Basically,
really weird,
you have a
you could have some weird things happen if you tried to use it just, say you went ahead like this. If I were to run like that, technically it's going to run immediately and it won't know what A and B are, and it'll blow up, or it'll give you some weird response that you didn't want.
Got it. So basically, it's like a snippet code where you want to use at some place, and right now you're not using it. So,
Yep.
Got it.
Perfect. Yep. All right. Well, I have taken you much longer than I intended to tonight.
This is super helpful.
but-
Thank you for being so thorough. Like, this was really helpful.
So I really want you guys to get these basic understandings. What I will do is I'll probably create another video and post it tomorrow, just to cover real quick the context, function chaining, and ternary operators. So I will cover those in a little video, and I'll post that into the Mattermost channel tomorrow. But as of right now, I'm thinking I need to call it for the evening. So does anyone have any additional questions before we go?
Yeah, will this be up tonight so I can finish like studying, or will this be up tomorrow as a recording?
I'm gonna try and get it up tonight. I do have one thing that I've got to run and do tonight before they close. So I'll get that one done as soon as I can. Hopefully it'll be up tonight. If not, it will be first thing in the morning.
Thank you.
Thank you. Yeah, this was so helpful.
Awesome.
Is this code from all of your files here? This isn't on the Learn platform. Did you make this for the lecture?
I did make this for the lecture. And so on this, I will take certain lectures. I will make my code available to you.
Okay.
I create a GitHub repository for